Today in 10.2 in Advanced Algebra 2, we talk about arithmetic sequences and arithmetic series. You should be familiar with sequences. That's what the previous lesson was on. A sequence is just an order of terms in a specific pattern. Arithmetic means there's a common difference. How do you find that common difference between them? You take like the term before a guy minus the term the term after a guy minus the term before it, like the second term minus the first term, or the third term minus the second term, or the 100th term minus the 99th term, right? The term after a guy, subtract away the term before him. Common difference should be an arithmetic sequence. There are two formulas. Both of them have their advantages. We will end up using this one today. This is the one that I showed you on the video, that the explicit formula for an arithmetic sequence, how do you say this out loud? How do you say that? A sub n is right. Different way though. What does it really mean? Like, how would you say, don't say a sub 1, don't say a sub 2. What does that really mean right there? First term, what's this mean? Second term, so what's that mean right there? The nth term. The nth term in the sequence. Any term you want. N is just a variable. So any term you want will be, what's that stand for? That common difference times the term number, n is the term number, plus, what's that mean? The what term? The 0th term. Where's the 0th term at? Right before the first term, right? A term can be any integer. Any integer. It could even be a negative term, right? You could have the negative first term, the negative second term, etc. Term numbers, though, must be integers. That's why when you graph those guys and you put the dots, you don't connect the dots together, because you can't have a 1.5 term or a 3/7 term or anything like that. So it says this is our explicit formula. The recursive formula we'll get to later, and we'll talk about it. Find the 13th term of an arithmetic. What? We have to be very careful that if it says sequence or series. Right? That's why you have a note card. You have all these formulas for sequences. You have them for series also. A sequence is just an order of numbers in some particular pattern. If it's an arithmetic sequence, there is a common difference. So here's what we're going to do. They want me to find the 13th term. I'd love to have an explicit formula for this. Start generic. The nth term will equal that common difference times n plus the 0th term. Cool? Which term do they want me to find? The 13th term. Cool? That means where you see an n, you will put a 13, because isn't 13 the term number, correct? So, a sub 13. Isn't there an n there? This, what do you say? How do you call that? What do you say right there? The 13th term is, do you know the common difference? It's right here. It's how much? Negative 6. Do you know the term number? It's 13. Aren't we trying to find the 13th term? I just need to know the 0th term. They tell me this. What's this mean right here? The first term's 21. If the common difference is going down by 6, down by 6, down by 6, down by 6, how do I go backwards and find the 0th term? Go up by 6. 21 plus 6 is how much? 27. So now let's compute. The 13th term is going to be negative 6 times 13 plus 27, baby. What's the 13th term in that sequence? Let's talk about the advantage to this. What kind of formula was this? He was an explicit formula. What's so great about an explicit formula? You could find whatever term number you want. If I ask you to find the 1000th term in this sequence, could you do it? Could you find the 1000th term in that sequence? Yes or no? Yes. A recursive formula, it doesn't work that way. You always have to know the previous term before that. So if I ask you to find the 1000th term, you can't do that without knowing the 999th term. Right? And how do you find the 999th term? You got to have the 998th term before it. You got to know the previous term to use a recursive formula. They do have their advantages somewhere down the line, though. Like, why is there two different formulas? Explicit is the awesome one. If they just tell you to write a formula, that means write explicit. they will always say, please write a recursive formula if they want you to write a recursive formula. Find the 20th term of an arithmetic sequence with this information. Start with the generic explicit formula. The more you start with the generic formula, the easier this stuff is going to be. What do we want to put in here? Which term do we want? So what do you want to write here? How do you say that? Don't say A20, A sub 20, because it's a little subscript, right? The 20th term equals, do you know the common difference? Difference is 4. My pen would want to cooperate. The term number is what? And I need the 0th term. They should tell you the first term is 15. If the difference is going up by 4, up by 4, up by 4, then how do you find the 0th term? Go down by 4 from the first term, and that would be how much? Now punch that in for me. I bet you can do it mentally. What's 4 times 20? 80, plus 11 more. The 20th term in this arithmetic sequence would be 91. Like if I listed them all out, if I went 15, then 19, then 23, and just kept going, right? When I got 20 of them in a row, I would hit 91. You see the arithmetic sequence started with 15 and it goes up by 4 every single time. Next guy, set it up for me. Start with the generic. Sub in what we know. And what would be the 0th term? If the first term is negative 81 and the common difference is going up by 12, up by 12, how do you go back and find him? Go down by 12. And what's my 0th term, baby? Negative 93? Sweet. Now you can punch that in. The 7th term of that, 12 times 7 minus 93, what'd you get? Negative 9. Feeling good? Feeling good? Next. Ooh, it's like the same problem, but with different information. What are they asking us to find here? If you know how to read it, you'll know what to do. What are they asking you to find? 31st term. The sequence is arithmetic. Ooh, what do I need to know, though? I need to know the common difference. First of all, should it be a positive or negative number? 18, 15, 12, 9, what's happened to those numbers? Going up or going down? So it should be a negative number, right? How do you find it? Any term minus the guy right before him. So you can do 15 minus 18, you can do 12 minus 15, you can do 9 minus 12. What's my common difference? Not 3. Negative 3. You with me on that? So let's start with the generic formula. A sub n equals the common difference times n plus the 0th term. Which term number do they want us to find? The 31st term. Common difference is negative 3. I got a term number of 31. And the 0th term should be the term right before the first term. So they're going down by 3. I got to go up by 3 and get my 0th term to be 21. Right? So now we punch her in. Negative 93 plus 21. Negative 72. Is that what you're getting? Awesome. Why don't you and pal get number 4 done for me? Please pause the video. Very similar to this. You need to know the common difference before you can get going. Be careful with that common difference. Start with generic, sub in. Common difference was 5. Correct, because you got to take negative 58 minus a minus 63, which is really a plus 63, and then you sub in, and hopefully we got 432. Piece of cake, right? Arithmetic sequences. Let's see what we got next. Write the explicit and recursive equations for the nth term of an arithmetic sequence. So, explicit, what we've been doing so far. Here's the sequence. Here's what I need to know first. Take a guess. What do you need to know? D, right? What's the common difference? So right above it, I'm going to say D equals. What does D equal? Negative 5 minus a minus 14, which is really plus 14. What'd you get? 9? Cool. So, organized work. Let's find the explicit. Please tell me explicit right here. That's spelled wrong. There's an I in there. Explicit. C-I-T. Explicit. That's a typo right there. The explicit formula, start with the generic. A sub n equals b times n plus a sub 0. And you should be able to do that. The thing is, you don't know n, right? You don't know which term number you want. We just want a generic formula for any term we want. So it's a sub n, any term we want. The nth term will equal. Do you know d? It's 9. We don't know n, but you can figure out the 0th term. If the first term is negative 14, and they go up by 9, up by 9, up by 9, go back by 9, and you get negative 23, right? This formula right here is the explicit formula that will allow you to find any term number you want. So like if I asked you to find the 13th term, couldn't you put 13 in for n in this situation? If I asked you to find the 100th term, you could put 100 in for n. Cool? Recursive. Recursives aren't as popular because you always need the previous term to fill it out. Here's the recursive formula. It's a two-parter every time. See this big old bracket? You need that bracket, but we'll put it last. You have to know the first term before you can get started. So that's why it says a sub 1 equals. I put a blank there. This is Colwell type. This and just left it empty. You got to fill in the blank. That's like free information right there. It's the first term. Do you know what the first term is? Negative 14. Right? Then any term after that will be this. A sub n minus 1. Notice the n minus 1 is as a little subscript. That means the previous term. Make a little note in that chart right here. This means the previous term. And let's see if you can understand this. If I ask you to do this, find the 13th term, wouldn't you need to do this? Figure out this. 13 minus 1 is how much? 12. If you want the 13th term, what do you got to know right here? This is really the what? The 12th term. Isn't that the previous term right before it? So that's why if this is the nth term, just take one away from it. Won't that always be the term right in front of it? The previous term. Then we need to add to it the common difference. Do you know the common difference in this situation? What is the common difference? It's 9, so plus 9, comma. Then this is the part that everyone forgets to put. It's typed specifically right here. Please find it on your little mint note card. Also, for integer n's, I don't put the word all. I just say for integer n's greater than or equal to 2. You need to restrict the domain because they're telling you what does n stand for. N has to be an integer, and it's got to be greater than or equal to 2 to work with. Why does it got to be greater than or equal to 2? Well, let's see what happens if it is 2. This is the second term, correct? What does that mean right there? What's the a sub 2 minus 1th term really talking about? What term would you get right there? The first term. Do you know what the first term is? What is the first term? Because you defined it up here, it's negative 14. Then you just add 9 to it. Wouldn't the second term be that negative 14 plus 9? What's negative 14 plus 9? I'll bet it's negative 5. Then when you want to find the third term, don't you need the a sub 3 minus 1 plus 9? What's the 3 minus 1? Isn't that the second term? Do you know what the second term is now? You always have to have the previous term beforehand to use the recursive formula. So n's got to be an integer. There's 4 parts to this guy. These are always worth 4 points in my eyes. 1 for putting this down, the first term. 2 for putting this part. There's part 2. 3 for putting this. And the 4th part is to realize that these go together. They're a packaged deal, so you got to put that big set bracket around it. That's how you find it. So let's talk disadvantage. Find the 100th term, and all you have is the recursive formula. A sub 100 equals A sub 99 plus 9. What's the problem that you have? You don't know what the 99th term is, do you? You have to find the 99th term before you can find the 100th term. If I ask you to find the 100th term here, could you do it? Because you don't see this guy. I need you to tell me out loud what he's called. What's he called? Previous term. Does this have any previous terms in it whatsoever for a formula? This guy involves the previous term. So let's roll with number 5 on the next page. They want both the explicit and the recursive formulas. Explicit. The explicit formula. Give me that generic first. Substitute in. Explicit is a piece of cake, especially if you did it on the homework like I asked you to. That was due today. You just don't know n. You'll know d is 38 because they told you so. And you have to figure out the 0th term for yourself. The 0th term, you got to take 15 and go down by 38. So what do you get when you go backwards by 38? Negative 23, right? So I got to get rid of my plus. Put minus 23. Then box it. Any questions about an explicit formula? You should be pretty cozy with that. That's not new. Awesome. Recursive. What will he have in him? What does every recursive formula have in him? Starts with a P. Previous term. You got to tell me what the first term is, though, right? Don't you have to at least get started somewhere? You better tell somebody what the first term is so they can get started, right? What's the first term? Now, how do you find any term after that? You take the previous term. Isn't this the previous term right here? And what do you do to him? You better add that common difference to it. What's the common difference? So wouldn't you take that previous term and just add 38 to it? Right? Anything else needed? For integer n's greater than or equal to 2. If you run out of space, you see how I wrote that as on top of itself? For integer n's greater than or equal to 2. And then you need to make the bracket. Let me show you. This right here is very much like this button on your calculator. A, N, S. If I asked you to do the recursive formula in this sequence, guess how I have to start? What would you have to start with? Like I want to type out the sequence. How do I start? What would I have to punch in? Whatever the first term is, and hit equals, right? Now how do I find the next term? I'm going to take the previous term plus 38, right? Isn't that what it's going to be? Then if I hit it again, doesn't it take the previous term plus 38? Doesn't it take the previous term plus 38? Previous term. What does ANS really represent? The previous term, right? So if you wanted to find like the 5th term and all you had was a recursive, you could just hit that button 5 times. You with me on that? But this, not so nice. Next guy, explicit and recursive. There's your generic. Start with him. I don't know, and the previous term, or the 0th term, you just got to go backwards. If your common difference is a negative 13, add 13 to your first term, and wouldn't you get 85? Is that right? 85? Recursive. See if you can do it without my help. Work with PAL if you want to, but there's 4 parts to a recursive formula. Use your Mint note card to help you if need be. This is what it should be. To read it out loud, the first term is 72. The nth term after that, how do you say that out loud? Will be the previous term minus 13 for all integer n's greater than or equal to 2. Yep. Now, it won't always necessarily be a 2. If it's an arithmetic sequence, yes. But if it's like the Fibonacci sequence or some other crazy sequences, there's other things, they might tell you the third term already or something like that. So you'd say the fourth term. Not for arithmetic, no. Next, got to do the same thing, explicit and recursive. First of all, what do we need to know? First term, I know it, it's 63, right? Isn't 63 the first term? So if you like to jot that down, a sub 1 equals 63. What else do I need to know? I need to know the common difference. What does b equal? 7 or negative 7? So give me an explicit formula and a recursive formula. Pause the video, give that a try. Get both of them done. You can check yourself on the video as you go. So we skipped that other one, all you people in video land. We'll jump down to arithmetic series now. Series. What an arithmetic series is, it's the sum of the certain terms of an arithmetic sequence. So they give you an arithmetic sequence. Isn't that just a listing of certain terms, right? Like this, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's an arithmetic sequence, right? How long could I go for, though? Forever and ever and ever and ever, right? Arithmetic sequences go on forever and ever and ever, hence the dot, dot, dots. What we want to do with a series is take a certain amount of terms and add them up, right, in that sequence. So, here's what happened. A man by the name of Gauss, with a capital G. When he was like, I don't know how old, maybe 9, he was in school, and their teacher was busy, needed some time, you know. Like, oh, forgot to do something. So he told all the kids in that elementary class to add up the first 100 natural numbers. 1, 2, 3, 4, all the way up to 100. Add them up. What would they all add up to? Carl Gauss did it like this. He figured it out. Gauss was a very, very smart man. And this was like at age 9 or 10. I can't remember. I got to look it up. He added them up real, real fast. I don't want to list out all 100 of them. It would take too much space. But here's the same problem with the first 10 natural numbers instead of the first 100. Here's what Mr. Gauss noticed. That when you have a listing of numbers in an arithmetic sequence, if you add the first term and the last term together, this is just the first 10 natural numbers, what do they add up to be? 11. Then he noticed this. If you take this term and that term and add them up, how much do they add up to be? 11. If you add this term and that term up, how much do they add up to be? 11. Then the next two terms, when you work away, what do they add up to be? And then finally, those two add up to be how much? How many sets of 11 do we have here? So don't we really have 11 times 5, correct? Or, as this formula says, capital S we'll use for series, right? Meaning the sum of how many terms are there in this case? 10 will be the number of terms over 2 times the quantity of, what's this stand for? The first term plus, this would be the last term, right? The nth term. And didn't we do 10 over 2 times 1 plus, what's the nth term in the sequence? The 10th term is what? 10. Well, what did that turn out to be? How many sets of 11 were there? Why do you have to take it in half? Why do you have to take it in half? Because aren't you pairing things up, right? Aren't you pairing things up, right? You paired them up, and didn't they add up to be 11 each time? So what did those add up to be? 55, right? You add the first term and the last term together, and take it by half the amount of terms that you have. Right there is what you really do. Cool? So if you wanted to do the first 100 terms, S sub 100 would equal 100 over 2. How many sets would you have? 50 sets, right? Times 1 plus 100. Isn't that 101, right? Take 50 times 101 for me in your calculator. Do that for me. 50 times 101. 5,050. And Mr. Carl Gauss at the age of like 9 years old, figured that out and blew his teacher's mind. He explained to him also that I just kept getting the number 101 50 times. So that is how we have this formula right here. There's formula 1 and formula 2. Please note these in your notes right here. Formula 2 right here is the one we want to use most often. But formula 1 will have its advantages. We're going to need formula 1 every once in a while. We'll see when we get there. But didn't you see that this is Gauss's formula right here? The sum of an arithmetic sequence, this guy right here, this series of n equals the number of terms you have over 2 times the quantity of your first term plus your last term in that particular sequence. Cool? And if people are like, what do you mean the last term? I thought you couldn't have a last term. Well, when you're trying to add up a certain amount of terms, you have to tell them how many do you want to add up. Like they said, hey, Gauss, add up the first 100 of these terms. Or add up the first 10 of these terms. Aren't I telling you a specific term number that I want you to add up? So find the series of n, the sum of all those bad boys, for this arithmetic series, with the first term being 14, the nth term being 101, and the number of terms being 30. This means like that's your last term right there. So let's start with this. Which formula do you feel you would use? Formula 1 or formula 2? The thing that formula 1 has in it that we'll need is that difference, right? That common difference. This mentions nothing about a common difference, so that looks like a formula 1. I like to start with the formula just to get started with, so you can learn to substitute in and see the ingredients that you need. Eventually we'll end up writing the formula down first, but we got to crawl before we can walk. Do you know S of n? S sub n. Do we know the sum of it? What do you think? That's what they want us to find, right? So we don't know it. Do we know the term number, though? Instead of putting an n there, what can we put there? 30. So this means the sum of the first 30 terms in this sequence. Cool? The sum of the first 30 terms will be 30 over 2. What's the first term? 14. What's the last term in this one? 101. It really means that it's the 30th term, because don't they tell us that n is 30, and then you put the 30 in right there. The 30th term is 101. You with me on that? So let's do it. You can just kind of punch it in your calculator if you want to from this point. But I hope you can figure out that that's 15 mentally. But I'm going to do 14 plus 101. Figure that out first. Times 15. 1725. Yes? No? Maybe? Cool. Next guy. Let's set it up. Find the indicated sum for each arithmetic series. So let's start with that formula 2 guy again. You realize that they don't care about D or anything like that. Let's start with formula 2. We don't know the sum, but we do know the term number. What is our term number? Term number is what? 12. So the sum of the first 12 terms would be 6 times 12 plus 100. Notice I just did that mentally right away. If you want to do that, instead of putting 12 over 2, you can put 6 right away. I don't care. And then you punch that in. 6 times 112 is how much? 672. Awesome. Try the next one. Why don't you pause the video, write the formula down, set that up, pause the video, get that done for me. Pretty simple at that point, right? They gave you all the ingredients you need for this formula. You need an n, you need a first term, and you need that nth term, like whatever that nth term is in the sequence. Now let's realize why we're in trouble on 11. Brainstorm, what's going different about number 11? There's two main differences. They tell us D, right, but we don't have N. Make yourself a note. What is N? You know, you'll need to look back at your notes to kind of do your homework on some of these. Right? It's like, what is N? Well, here's the way I roll with it. If I know the first term, and I know any particular term in the sequence, and I know the common difference, I'm going to use the explicit formula for this guy to figure out n. Cool? So isn't that this? We got to find n first. You're going to have two columns of work right here. So go over to the left, and let's do this. A sub n equals d times n plus the 0th term. Cool? It would just be pretty messy to substitute all this stuff into Formula 1 right here. This is going to be a quicker version of it. Awesome? Do you know the nth term? It is 112, correct? So that goes right now. Do you know d? It is 4. But do we know what n is? No. Can we figure out the 0th term fairly easily if we know the first term and we know the common difference? What's my 0th term? Is it 24 or 16? 16. Cool? Solve for n. Subtract 16 from both sides. 96. 96 divided by 4 turns out to be what? Here's the thing you have to get for n. N has to be an integer. Doesn't it represent a term number? If you get a decimal, you made a mistake. Right? N has to be an integer. Now, squiggle, 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 squiggle. Now we know n, let's use formula 2. Because don't we know n? We know the first term and we know the nth term, correct? We know it all. You can stop writing that formula down if you want to at this point. And I got n over 2 times the first term, which is what? What's the first term? 20, plus the nth term, which is 112. So I got 12 times 132. I'll let you punch that in for me. Rock and roll? That's a method. I'm not saying you couldn't do it by using this formula right here, but you actually can't. Let's kind of understand why, because here's what you don't know. You don't know this, and you don't know this. Isn't that n, correct? You do know d, and you do know the first term, but is there anything else that you don't know? Did you know what s of n was? They didn't tell you that, so you're missing two things. You couldn't use that formula. Discuss what you'd do on number 12. What would you do? Here's how I talk it out. The first thing I'd like to use is this. This is plain Jane simple. Do I know a sub 1? Yes or no? So I'm just going to say I know him, right? Do I know a sub n? Nope, I'm missing him. Do I know n? Yep, I don't need him. Do I know s of n? I'm missing two things. Can I use that formula? Nope. Over here, let's see. Do I know d? Yep, so I don't need him. Do I know n? Done, done. Do I know the first term? Only thing I don't know is this, right? S of n. Can I use that formula? Isn't that what they're wanting us to find anyway, is the sum of that sequence? So the only thing I don't know is the sum of that sequence right there. So S of n will equal n over 2, 8 over 2, times 2 times the first term. What's the first term? 42, plus the quantity of n minus 1. Can you do that mentally? What's n minus 1? 7. Times d, which is what? Which is what? 6. Brackets closed. Let's clean some stuff up. 4 times, working from left to right, 2 times 42 is, plus 7 times 6, which is 42. Right? Then I got to do that adding part. Adding. Or adding, however you want to say it. Adding 126, is that right? Times 4, help me out. 504. Good deal? Is that what they wanted us to find? Feel good with that method? How did I figure out to use Formula 1? I looked at my ingredient list and realized I was only missing one thing out of that formula. All groovy with that? Let's try again. Woo! They want me to find 8 plus 6 plus 4 plus blah, 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 all the way up to negative 10. Is this an arithmetic series? Is it the sum of an arithmetic sequence? 8, 6, 4. Do you have a common difference between these? What's the difference? What is it? Negative 2. So I define that right away. I'm actually going to do it right here. I'm going to say, I know the first term. Do you know the first term? What's the first term? 8. Do you know the a sub nth term? Do you know like the last term in this particular series? Do you know the last term? Negative 10. Do you know d? D was what? And then I just need to know how many terms there are. Isn't that missing? Correct? I'm missing the term number. Correct? These are the main 4 ingredients. The first term, the nth term, the common difference, and how many total terms there are. Cool? So, what do you want to do? How did we find n before? Look back to the previous page. On the previous page, we made a note that said, what is n? We found it over here by starting with the explicit formula. Let's see if that works for us again. A sub n equals d times n plus the 0th term. Do I know a sub n? It's negative 10. I know my difference is negative 2. I just don't know n. And the 0th term would be positive 10. Righto? Solve for n. Solve for n. Better get an integer back when you find an n value. What's n? 10. Squigglies. Now, can we use this formula? Formula 1. We know n, we know the first term, and we know the nth term, correct? What we don't know is the sum of them. Use that formula. S sub, don't put S sub n though, S sub what? 10. The sum of the first 10 terms will equal. I got negative 10. Is that what you get? Sweet. Do it again. Start here. They give me a whole series. A sub 1 equals, A sub n equals, D equals, and n equals. See if you can fill those 4 things out. What an ideal process. Find an n. There's where our explicit formula helps us. 1, 1, 2 is the nth term. The difference is 6. And the 0th term would be 10. Is that right? 10 is the 0th term? Yeah! 102 equals 6 and n better be an integer. Oh man, I hope 102 divided by 6 comes out nice. What'd you get? 17. That means there are 17 terms in this series. I keep saying sequence, I'm sorry. There are 17 terms that we're going to add together in this particular series. So the sum of those 17 terms will equal half of those, 17 over 2, times the first guy plus the last guy. So if I added those together, 16 plus 112, you'd keep getting those groups of 128 to show up. How many of them would show up? 17 halves of them. So I got to take that times 17 divided by 2. I just made that in parentheses. And I should get 1,088. Is that what I said? 1,088? Yeah. Yes, sir, Bob? Cool. So it's a lot of different concepts today, just like your homework. Look back to notes to help you do these. It's like, how did we do problems like this? How did we do problems like this? Oh, how did we do problems like this? What do they want you to find? The first three terms of an arithmetic series. Right? Here's our two formulas for arithmetic series. Let's figure out which one's going to help us. Formula 1 or Formula 2? To figure out which formula you'd use, you want to substitute the stuff in, sort of, kind of, and see if you're missing just one variable. Would you agree that this is our formula of choice, right? I'll try him first. Do I know S of n? Yes or no? Boom. Do I know n? Missing, right? So I circle him. Just think, do I know the first term? Do I know the last term? Will this work for us? Am I only missing one variable? We can use this guy. So let's start with him. S sub n equals n over 2 times a sub 1 plus a sub n. And substitute in what you know. We know the whole sum. I just don't know how many darn terms there are. 8 plus 100. What would you do to get rid of this? Divide by 2. Multiply both sides by 2. That would give me a 2592 over here. Is that the right number? 2592. And then over here, you're left with the 108 times n. Right? You see where the 108 came from? And it had to be multiplied by n. When you multiply every side by 2, this times 2 and that divide by 2 cancel each other out. And you're left with 108n over there. Yeah? N equals 2592 divided by 108, which is awesome. How does that help us? So we know what? What does this stand for? There's 24 terms in this particular series. We want the first 3 terms, right? What don't we know that we need to know? Do you know the first term? Yes or no? You know the first term is 8. What do you need to know to figure out the second term? Like what D equals, right? I need to know what D equals. Cool. Watch this. Will this help me? Don't write it down. Just see. First of all, can you tell me what this is? That's the explicit formula. Will it help me? Do you know A sub n? Yep. Do you know D? Do you know n? Do you know the 0th term? How would you find the 0th term? If you know the first term, you can always find the 0th term by using the difference with it, correct? Do you see how we can't find the 0th term because we don't know D? So this particular guy, unhelpful. Look at your mint note card, though. What's the real explicit formula for an arithmetic sequence? The nth term will equal the first term plus the quantity of n minus 1 times what? This, we have to use this guy this time. Why? Because we don't know D. But do you know everything else? Do you know n? Do you know the first term? And do you know the nth term? Substitute into this formula. Write them down so that way you can see what you did on your notes. This is the explicit formula for an arithmetic sequence. It just so happens, though, that it's different than the one we're using. It doesn't involve that 0th term at all. But A sub n is 100. The first term is 8. N minus 1 is 23 times D. All right, I did a little mental. N was 24. I took it minus 1 right away and got 23. And now 92 equals 23D. Right? Do you have to get an integer for D? Can the common difference be a fraction? Can you go up by a half every time? Yep. What's the only thing that has to be an integer? n. What's 92 divided by 23? Now, do this right below. A sub 1 equals, A sub 2 equals, A sub 3 equals. Because that's what they're asking us. Find the first three terms. If you get this wrong, I'm going to be mad. What do you got here? What do you got here? Now do you know the common difference? So what's this going to be? And what's this going to be? Box it. Let's see if we can try it again. Woo! We had to figure out n, and we had to figure out d. Let's see what we do on the next problem. Whoa, is that it? I skipped 16, right? Oh, it's right here. That's why. Cool. So let's try the next one. Which formula would you use? Figure it out. Helpful hints. Look at the given information. Is it the same given information as before? Yes or no? Not quite. They give us the series, like the sum of it, right? S of n. They give me the nth term, but now they tell me n, right? Well, let's see. Can I try my trusty formula? Can I use him? All I want to do is have one variable missing. Do I know S of n? Do I know n? Do I know the first term? Do I know the nth term? All I'm missing is one thing. Can't we still use that formula? So let's do our 1098 equals n over 2, which I got 18 over 2, times the first term plus the nth term. Yes? This is really a 9. So 1098 equals 9 times the quantity. If you choose to distribute, you can do that. You can totally distribute the 9. But you can just get rid of this times 9 in front of the parentheses by doing what? Divide both sides by 9. What's 1098 divided by 9? 22? 122. Agree? Disagree? Divide by 9. Right? Get rid of the times 9 in front of that parenthesis. Is that what we got? Yes or no? What's left over here then? Cool. Solve for the first term. What's the first term? Agree or disagree? First term is 10? Awesome. Now what? We want to use, we need to know what? If you know the first term and you want to find the next three terms, what do you really need to know if this is an arithmetic series slash sequence slash series slash sequence? What do we really need to know? D, right? Should you use my explicit formula or the note card's explicit formula? Note cards, which says the nth term will equal the first term plus n minus 1 times d. That's what it says, right? That's the note card's explicit formula. Why? Because you have all the ingredients except for D. You got the first term, you got the nth term, you know n, you just don't know D. Man, you don't know D. First term is 10. N minus 1 is 17. Be careful when you're subbing in. That's why I write the formula down first. It really tells me that I'm putting the numbers in the right place. That common difference can turn out to be a decimal, right? It's not a term number, it's just a difference. What did you get? 6 is what you should get. Now answer the question. The first term equals, the second term equals, the third term equals. Holy cow. First term is 10, 16, 22. Is that what we get? Yep. Cool. You'll rarely see the sum of an arithmetic sequence written like that. You'll see the Greek letter sigma. Fancy looking E type thing. You've probably seen it if you drive by a sorority house or a fraternity house. the SAE, sigma, alpha, epsilon. This is the sigma. Capital sigma is what it really is. Sigma means sum. Sigma means sum. They just defined a Greek letter to stand for it. What does sum mean? We want to do what? Add, multiply, divide, subtract. Add them up. Sum means add them up, right? So here's the thing. Here's the shorthand notation for adding up the first 5 terms in this particular sequence. Isn't the sequence 6 times n, right? Where if you let n be 1, wouldn't the first term be 6? If you let n be 2, wouldn't the second term be 12? And et cetera, et cetera, et cetera. How many terms are there right there? 5. They started with which term do they want to add up? The first term through the 5th term. Do you see those little numbers right there? They wanted you to add up, in this particular sequence, the first term through the 5th term. Well, here's what we do. Here's a whole new problem. This is an arithmetic sequence. Cool? This is your common difference, and this is your 0th term right here. Just like a sub n equals b times n plus your 0th term, isn't this your difference, n, and 0th term right there? Cool? Here's what we need to find. We need to use these little bitty indexes right here. We need to find, check this out. What if I let k equal 1? If I let k equal 1, this would happen. When k equals 1, don't I substitute a 1 in for k right there? I get 3 times 1 plus 4, which is how much? So that means that the first term in that particular sequence is 7, right? If k was 1, the first term is 7. Y'all comfy with that? What if I let k equal 2? Well, this would happen. I get 3 times 2 plus 4, which is really 10, right? That means that the second term is 10. Y'all cozy with that? I'd go all the way up to when k equals 18. Tell me what we would really be finding if I put 18 in for k. What would I really be finding? The 18th term, right? So if I let k equal 18, you'd get 3 times 18 plus 4, which is 58. So the 18th term is 58. Awesome. Well, what we need to do is then figure out how many terms there are, right? So I know the first term. Let's write this down now on your paper. Tell me that the first term equals 7. Y'all comfortable with how I found that? I put whatever this number is in for k, right? That's my first term. Then I want to find the 18th term, which would be 58. Cool? Now I need to figure out how many terms there are. Here's what you do. Let me see where it's at. Write this down. The number of terms will be this. Number of terms. Don't we usually call that n, right? N is the number of terms. It's your high number minus your low number plus 1. High number, that's this guy, the high number, minus your low number, that's that guy. Then just add 1 to it, because you have to include that term, right? That guy counts. So let's just start with this guy. Okay? Let's just start on the next page. We're running a little short of time, so we could skip that previous guy. Let's start with this guy. This is a total series right here. I got a series with this particular pattern. I don't want to add up every term. It's impossible to add up every term because we go on forever. They're saying, please add up the 18th term through the 42nd term, is what they're asking. Not even starting with 1, right? You're not even starting with the first term. They just say, hey, if we list them all out, what would the 18th term through the 42nd term add up to be, right? The sum of the 18th term through the 42nd term. So here's what we do, though. We always call it our first term in this situation. That's when we put 18 in. So I'm going to show a little bit of work. I'm going to say my first term is 4 times 18 minus 9, which is really something. Punch that in for me. The first term that I would start with, when I had them all listed out with, wouldn't you start with the 18th term, right? Well, that's the first term that I would use, and that would be how much? What'd you get? 63. Cool? Then I'm going to do this. I'm going to say the nth term, which would be like the last term in my situation, would be when I got 42 right there. So 4 times 42 minus 9. I just put 42 in for n, which is how much? 159. Is that what you get? And then the last thing I got to figure out is how many terms there are. So we're going to do it like this. N equals 42 minus 18 plus 1. Isn't it your high minus your low plus 1? The high number was 42. The low number was 18. And then you add 1 to it. What you got? There are 25 terms in this series. Well, there are 25 terms. If you added up the 18th through the 42nd term, you'd be adding up 25 different guys. You with me on that? The first one that you'd start with would be number 63. Then you'd all add up all the way up to that number 159. So now we use formula 2. S sub n equals n over 2 times a sub 1 plus a sub n. And we know all the ingredients that we want. The thing we don't know is this guy. But the sum of those 25 terms would equal, what's n again? 25 over 2. What's the first term that we started with? 63. What's the nth term, if you will? 159. Punch that in for me. Two seven two. Excuse me. 2775. Is that what you get? Take 63 plus 159 in your calculator. Hit equals. Then take it times 25 divided by 2 in parentheses. 2,775. Awesome. Next, a sub 1 equals 3 times, what are we putting in? 20 plus 4, which equals 64. Awesome. Put 20 in for n, because that's the first one we'd start with. Then a sub n equals 3 times, what are you putting in? 50 plus 4, which is 154. We all in agreement to that? Now find n. High minus low plus 1. High minus low plus 1. 50 minus 20 plus 1 equals 31 terms. Is that right? Cool? Because if you count up the 20th through the 50th, people are like, isn't that 30 terms? No, you have to count the 20th term also. That's why you add 1 to it, right? The 20th term, the 21st, etc. So then the sum of all of those would equal the first term plus the last term times half the number of terms. 31 over 2. First term is 64. The last term is 154. To the calculator I go. 154 plus 64 times 31 halves. The sum of those, this should be a 31. 3379. Yes, sir, Bob? Let's jump down to 21. Find the arithmetic means in each sequence. This is a sequence. Cool? How many blanks are there? How many blanks? 4 blanks. But don't you have to take the common difference and add it to this 5 different times, right? So here's what we need to do. The D will equal whatever term they listed minus the first term, which would that turn out to be plus 8, minus a minus 8, divided by, how many blanks are there? 4 blanks, but you need 5 different multiples to get up there. So the blanks plus 1, which is how much? 5. What's 22 plus 8? 30 over 5, which is really what? 6. The common difference is 6. Because there's 4 missing numbers, you need to add 6 to this number 5 times to be able to get up there, right? So if I add 6 to it, wouldn't you get negative 2? If you add 6 to it again, wouldn't you get 4? If you add 6 to it, you'd get 10. If you add 6 to it, you get 16. If you add 6 to it the 5th time, would you get to 22? blanks plus 1. Make yourself a note. Blanks plus 1 is what that number is right there. So let's do it over here. The difference will equal that last guy minus the first guy over blanks plus 1. How many blanks are there? 3. Add 1 to it. Because you got to add that number to it 4 total times to get up to 45. What's 45 minus 21, baby? 24 over 4. What does B equal? It doesn't always turn out that the common difference is 6, but now you just got to add 6 to this number. What's 21 plus 6? 27 plus 6 more. 32 plus 6 more. 33 plus 6 more, which is 39, right? Plus 6 more, you better get to 45 back.